Hello all. In this lecture, we are going to study about effects of electric current and their use in measurements. Consider there is a conductor here, okay? This conductor is nothing but a straight wire. Inside this conductor, there will be millions and trillions of atoms present. Now, because it is a conducting material, these atoms will consist of electrons or charge carriers in their outermost orbit, which will be randomly flowing in this conductor. Now when we connect a voltage source across this conductor, this voltage source will make the electrons to flow in one direction, and that is how electric current starts flowing through the conductor, and it takes this path in this circuit. Okay. Now, as the current is flowing through this conductor, what are the effects produced by this current flowing through the conductor? That we are going to study in today's lecture. Also, how these effects are used in measurements, that also we are going to see. So let us see the first effect. For understanding this effect, we have considered the same circuit. The current is flowing through the conductor, and as the current flows for a long period of time, the conductor gets heated up and thus its temperature increases. This is called as heating effect. This is used in instruments as ammeters, which are used for measuring current, voltmeters for voltage, wattmeters for power. Now this you can also understand by the example of your mobile phone. If you are suppose playing a game on your mobile phone for a very long period of time, after some time it gets heated up. So that is called as heating effect. Let us see the second effect. This is the magnetic effect. For understanding this also, let us consider the same circuit. We have this conductor which is energized by this voltage source, and now there is a flow of current in this direction. See, actually the current flows, the charge carriers flow from negative to positive, but conventionally we consider the direction of current from positive to negative terminal. So that is why this direction of current is in this path. Now as the current is flowing through the conductor, there will be a magnetic field produced around the conductor. Okay. Now here we have taken the same circuit, but the only difference is we have changed the polarities of the battery here. Now what will happen? The current will flow in opposite direction. Now also there will be a magnetic field produced around the conductor. Now what is the difference between this magnetic field and this magnetic field? The difference is in the direction. Here, because the current is flowing in this particular direction, this magnetic field will have one direction, and this magnetic field, because the current is flowing in opposite direction, will have opposite direction as compared to this magnetic field. Suppose say this magnetic field is in anti-clockwise direction, then this magnetic field will be in clockwise direction. You see here this pink dot, this is nothing but your conducting plate or conducting wire, and this is the magnetic field. Always the magnetic field is represented in the form of magnetic field lines. These are the imaginary field lines, and these arrows represent the direction of magnetic field. Now let us understand some more details about this magnetic field. This is the magnetic field which is produced in the first circuit. This is our conductor, and this is the magnetic field produced in the anti-clockwise direction. Also we have another magnetic field here which is produced by this north pole of a magnet, and there is a south pole of a magnet. When you have this condition, there is a magnetic field produced between these two poles, which is represented by this magnetic field lines. Okay, so you have this magnetic field, one magnetic field, and this is your second magnetic field. Now what I do, I take this conductor which is carrying current and has got its magnetic field, and I place this conductor in this magnetic field. Then what will happen is the magnetic field of this conductor and this second magnetic field, both of them will interact with each other, and there will be a force produced in this direction. If we consider the second case wherein your conductor was having magnetic field in the clockwise direction, and if that conductor was placed in this magnetic field, then there would have been force produced in the opposite direction as compared to this force. Okay. Now let us consider that the straight conductor is now converted as a coil. If this coil is given energy, if this coil is energized by this voltage source, then there will be current flowing through this coil, and this coil will also produce magnetic field. Each turn of this coil, this is one turn, second turn, third turn, and so on. So each turn of the coil will produce magnetic fields, and all the magnetic fields will get added up, and there will be a magnetic field produced here. So the coil here will act like a magnet. Now if we bring a soft iron piece near this coil, which is behaving like a magnet, then this soft iron core, this soft iron piece will get magnetized, and this will be attracted by this coil. This iron piece will be attracted by this coil, and this effect is used in attraction type of moving iron instruments. Similarly, if we bring another soft iron piece near this, so there are two iron pieces which are brought near this coil which has got magnetized, then there will be a repulsion taking place between these two iron pieces, and this type of effect is used in repulsion type of moving iron instruments. So this is the second effect, magnetic effect. The third type of effect is electrostatic effect. In this effect, what happens? There are two plates which are charged. Suppose there is positive charge here, negative charge here. Then there is a force exerted between these two. There is a force created between these two charged plates. And this effect is used usually in voltmeters. The instruments which make use of this type of effect are called as electrostatic instruments. So this is the third type of effect. The next type of effect is induction effect. Let us see what happens here. Suppose you have this iron core and there is a coil wound on this core. These lines you can see here, this is nothing but the coil which is wound. Okay, coil is wound around this core. And to this coil we have connected an alternating voltage source. So what will happen? There will be current flowing through the coil, and as there is current flowing through the coil, it will get magnetized. That is, there will be a magnetic field produced around the coil. This is how this coil behaves like a magnet, and it is called as an electromagnet. Now if we bring a disc near this coil, then there will be an EMF induced in this coil. Now if we are providing a closed path for this disc, then this induced EMF will cause current to flow in this closed path. Now you have current flowing, which means that there is magnetic field produced here. Also there is a magnetic field produced here. So because of the interaction of these two magnetic fields, there is a force produced on the disc and the disc starts moving. This is the induction effect, which is used in ammeters, voltmeters, wattmeters, integrating meters. The next type of effect, the last type of effect, is Hall effect. In this, let us see what happens. This is a conducting plate taken, okay, and it is connected to a battery. With this positive terminal, negative terminal, it is connected to a battery. As it is connected to the battery, current will start moving in this direction. Now if we are connecting a voltmeter here, this voltmeter will show a reading as 0 volts. Why 0 volts? Because this is as good as there is a short here. So this will show 0 volts. But now if we are providing a magnetic field here, there is a magnetic field provided by these magnetic field lines. Now what will happen? As these charge carriers in the sense current was flowing because of this battery. Current is nothing but charge carriers. Current is made up of charge carriers. As the charge carriers are brought in the influence of this magnetic field, there will be an EMF produced in this plate, and there will be charges produced at this edge. Also there will be charges produced at this plate. Now if we are measuring the voltage, now there will be some value of voltage available here on the voltmeter. Okay, and why these charges are produced here, why this EMF is produced here? EMF is nothing but electromotive force, okay, which is nothing but voltage. So why are these charges produced here? Because as the charge carriers come under the influence of magnetic field, there is a force called as Lorentz force acting on them, and that is why There is an EMF produced here. This type of effect is used in flux meters, which is used to measure the magnetic flux, emitters, Poynting vector meter. So that is all for this lecture. See you in the next lecture.